At 5:09 a.m. local time on June 22nd, the ground began to shake in parts of Ukraine's Crimea. This was surprisingly not due to military activity, but rather represented a purely tectonic earthquake large enough to be felt, something that isn't all that common in Ukraine. Across the next 9 hours, a total of 5 additional earthquakes struck in essentially the same location, with the combined 6 earthquakes registering in as between magnitudes 3.6 and 4.5. While this caused no damage, it is a reasonable question to ask, but why did these earthquakes strike? The answer relates to the area's geology and plate tectonics, as a peculiar area of Ukraine is more seismically active than most people realize. You see, Ukraine's largest earthquake in historical times was a magnitude 6.7, which is stronger than the biggest earthquake of most European nations. That earthquake occurred on September 12, 1927, 80 kilometers east-southeast of Sevastopol, generating widespread damage, causing casualties, and even a 2-meter-high tsunami. But most interesting about that earthquake is that it caused large volumes of natural gas to seep out of the ocean floor, rise to the surface, and then ignite, producing vast fireballs similar to those seen when methane at certain mud volcanoes ignite. That 6.7 earthquake occurred as part of a broader 3-month-long sequence which involved 4 magnitude 6 range earthquakes and 8 magnitude 5 range earthquakes. All of these events struck on or in close proximity to a massive increase in the depths of the Black Sea, with this slope being known as the Crimean Continental Slope. Generally speaking, the higher elevation an area is, the thicker the piece of crust associated with it is. The opposite is also true, as the crust floats on top of the upper mantle, maintaining an isostatic balance. Thus, it should come as no surprise that the crust is thinner in the deepest portion of the Black Sea than it is above the aforementioned continental shelf. This means that while yes, this is a huge oversimplification, any northward stresses the deeper portion of the Black Sea experiences will push it as a block into the continental shelf. That creates a zone of compression where the two areas collide, forming a series of primarily reverse faults that accommodate this motion. In other words, the area on and near the continental shelf represents the most likely specific spot for stress from distant tectonic plate motions to be released, as 2 different thicknesses of crust collide and compress against each other. The distant tectonic plates triggering this motion are a combination of the Eurasian, Anatolian, and Arabian plates. While there is not enough information to verify which fault line and fault type these earthquakes occurred on, they all seemingly occurred on a single fault line that was a reverse fault. One scientific paper suggests the existence of an unnamed minor fault line whose location I have roughly outlined, and I think that small up to 2.4 kilometer long segments of that fault line slipped, being specifically located deep in the crust where rifted continental and oceanic crust exist. Now, do you see the raised ridge which marks the boundary between 2 deeper sections of the Black Sea? That marks an ancient spreading ridge which emplaced new oceanic crust in a back-arc setting that was most active between 105 million and 85 million years ago. Multiple faults and fault zones exist on portions of the continental shelf, denoting the zone of compression most pronounced offshore of Crimea. I hope that you found this video interesting. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.